Hello student, welcome to my class. Last class we discussed what is simple microscope and how can we calculate magnifying power of simple microscope for maximum case and minimum case, means maximum magnification and minimum magnification. That means if we want to see the image of a microscopic object, then we have to use instrumental or optical instrument that is known as microscope. If this image is not clearly visible by the microscope, then we need to use another type of optical instrument that is known as compound microscope. Clear? So there is two type of microscope, simple microscope and compound microscope. So we already discussed what is simple microscope. Now we will discuss here compound microscope. So what is compound microscope? It is the type of optical instrument which able to see the clear image and magnified image of a microscopic object if microscopic object is placed nearby the instrument. Clear? So now we have to draw a ray diagram of compound microscope. Diagram is important here. We need to use two lens of small focal length. Suppose there is a principal axis, and first there is a lens of small aperture. There is one lens and its optical center, suppose here, that is C1, and the ray which pass through the optical center or the straight line which pass through optical center is known as principal axis. Clear? Okay. Next, suppose this lens is known as objective lens. Objective lens, and suppose it is L1. This is optical center C1, and there is a focus point. If this is objective lens, so you can write here this is F0, and this distance also take F0. F0 means focus point of objective lens. So we take here that is F0 and this point is F0. So suppose there is a object, small object which lies beyond the focus point, then the object which lies the beyond focus point, then the image will be inverted and magnified image which is beyond the 2f. Clear? For convex lens. So if object lies between focus and optical center, then we get a virtual image which we discussed in our previous class, that is simple microscope case. Now we will discuss compound microscope. So there is a object AB which is situated on the principal axis beyond the focus point, and the ray which is parallel to the principal axis after refraction through the refraction through the lens or objective lens is passed through the focus point. This is direction. Clear? Again, if we take another ray, and the ray which passes through the optical center, it travels undeviatedly, means it travels straight line path like this. And finally meet this point. Clear? So there is a image formed, and this image we can write here. This is final image formed by an object AB. So we can write that is A dash and image which is B dash. So when object AB is placed nearer to the objective lens, at that time we get a real image, and this real image is inverted image and magnified as compared to the object. Now second thing, because in compound microscope we have to use two lens of small aperture, but if we compare these two lens, another one lens is here also, there is another one lens, and this lens is known as eye lens or eyepiece. Eye lens or eyepiece, or you can write that is L2. If we compare first lens L1 and L2, then aperture of the L2 is greater as compared to L1. But these two lenses have small focal length. But this, if you compare first L1 and L2 lens, then the lens L2 has greater focal length as compared to L1. Now, this is the image ADS BDS of first lens and the object AB, which is situated on the principal axis. Now we have to adjust the second lens, or we have to adjust this eyepiece in such a way that the image formed by objective lens, that is ADS BDS, and this image which lies between this optical center, suppose C2, and here there is the focus point, that is FE. What does it mean? That means we have to adjust this lens L2 in such a way that the image produced by objective lens will be produced within the focal length of second lens, or within the focal length of the eyepiece. Clear? So here this is FE, and there is another point, this point also FE. FE means focus point of eyepiece, F0 means focus point of objective lens. Again, and this image is now acting as a object for second lens. Why? Because this image is now within the focus point and optical center. So when object lies between focus and optical center, then we get a virtual image and magnified image, and this image of this object, because this ADS BDS now behave as an object for lens 2, and its image will be formed here, and that image is virtual image. So the ray, now take two rays, the ray which is parallel to principal axis, after refraction through the second lens is passed through the focus of the eyepiece. So this direction. Clear? Now another ray. If a ray which passes through the optical center, it travels undeviatedly. So we can take here. So the ray which pass through optical center of second lens, or this is eyepiece, then it travels undeviatedly this direction, and the ray which is parallel to principal axis, after refraction through eyepiece, it passes through the focus point. We draw its line of action. Then this is backward extended of the ray, this ray, and if we extend also this ray which passes through the optical center of the eyepiece, then these two rays are meet at a common point and this point. Clear? And finally we get a image here, and this image, suppose we can take here, and the final image form, which depends on the length of the tube or length of the microscope. So this is final image formed here, and if this is ADS and BDS, we can take it, that is A double dash and this is B double dash, and this angle is 90 degree, and here also this angle is 90 degree. But there is a eyepiece, or we observe from this point here. So this is eyepiece, Clear? So finally, if we observe this point, then we get a virtual image which is a double dash and b double dash, and this is the final image, but here the object is AB here. So again I repeat my sentence. When object AB is situated beyond the focus point of objective lens, at that time we get a image A dash and B dash, which is real and inverted image and magnified image as compared to object. Now we have to adjust the second lens in such a way that the image formed by the first lens, that is A dash B dash, will be formed or will be placed in between focus point and optical center of eyepiece or second lens. So now this image of first lens A dash B dash behave as a object for second lens, and this object is now lies between optical center and focus point of eyepiece. Clear? And we already know if object lies between focus point and optical center, we get a virtual image, and this image form and this image appears to meet at this point. So we get a final image, that is A double dash and B double dash, which is virtual image and magnified and erect, because this side is object and this side also image. So this is erect image and this is magnified as compared to object, and this is virtual image. This is final image form. So A double dash B double dash is final image formed by eyepiece, and due to the object which is situated beyond focus point of objective lens, that is A B. Clear? Suppose this distance we can take. This distance is focus distance and this distance is taken to be, that is U or V naught. Suppose this distance is V naught. This is final image formed by the objective lens. So we take here V naught. Clear? And this distance from optical center to A dash and B dash, this is behave as a object for eyepiece. So can write here, it is UE. UE means object distance from the eyepiece. Then we get the final image, this image, and because this is optical center, so we have to measure this distance from here, and this distance is, that is VE, which is suppose it is at a least distance of distinct vision, so you can write that is D. Clear? Okay. Now we have to find magnification. So magnification produced by compound microscope. So first now we have to find magnification or magnifying power. Magnifying power, and it is represented by capital M. So what is magnifying power? We already discussed in simple microscope case. Magnifying power is defined as, that is, it is the ratio of angle subtended by final image, angle subtended by final image at aided eye divided by angle subtended by object at unaided eye. So we already know about what is aided eye and what is unaided eye. Unaided eye means naked eye without any eyepiece or without any lens, but aided eye means this eye is known as aided eye. And when we observe this image here, due to this lens and due to this lens, and this is object and this is final image and this final image due to this eye, and here we use a word, that is aided eye. And unaided eye means, suppose this object is situated here, if we observe this point, if there is no lens, then this object is known as, if we observe this image of an object, then that is known as unaided eye or if we observe the image of an object without any lens, or we can say that this is for naked eye, at that time we use a word that is unaided eye, and so this is the magnifying power of a compound microscope. Or simply we can write angle subtended by final image at aided eye. Angle subtended by final image, which is A double dash and B double dash, by this is aided eye, and this angle is known as, we can write this angle, suppose beta. So magnifying power in case of simple microscope, that is M equal to here beta divided by angle subtended by object at unaided eye. Unaided eye means, suppose here there is a object, and this object here AB, and this is suppose principal axis AB, and if we observe this point, this is known as unaided eye or naked eye. At that time the angle formed by the object at eye or unaided eye, this angle is known as alpha. Or we can take, suppose this is the height of object H, and here alpha is known as angle subtended by object at unaided eye, and this is the maximum distance, and this distance is known as normal distance, and which is denoted by capital D, least distance of distinct vision. And here this alpha is constant quantity for unaided eye. Clear? So this angle is known as alpha. Or you can draw here another angle. If we suppose this is the eyepiece, if there is no lens, then we can draw a angle here, and this angle will be represented as alpha. Clear? And this angle which is represented as alpha, and alpha equal to H by D, because alpha is here a very small angle. So you can write angle subtended by object at unaided eye, and this angle which is a constant quantity, because if we decrease this distance, then we cannot able to see the image. Why? Because this is normal distance, and the normal mean distance of distinct vision, which is equal to 25 centimeter. This object is situated at a 25 centimeter, which is constant quantity. So you can write here alpha. But here alpha, beta are a very small quantity, so they can be replaced by their tangent. We can write here that is tan beta, which is nearly equal to and tan alpha. Now we have to find the value of tan beta and tan alpha. So there is a triangle, right angle triangle, A double dash, B double dash, and C2. This point C2, or this beta can be calculated from this triangle A dash, B dash, and this C2. Suppose this object here and this object distance is taken to be H. Now this is the image A dash and B dash. Suppose it take H dash, and finally A double dash and B double dash, we can take H double dash. Clear? So now we have to find for tan beta. Now tan beta equal to, in triangle we can take any triangle A double dash, B double dash, C2, and A dash, B dash, C2. If we take this small triangle, then in right angle triangle A dash, B dash, C2, and here tan beta equal to perpendicular upon base, and here perpendicular, because this base, this is base angle, so it is base and this is perpendicular, that is A dash, B dash, A dash, B dash divided by base, and base is here A dash, C2, A dash, C2, which is equal to A dash, B dash, we take here H dash, so we can write H dash divided by A dash, C2, A dash, C2, that is UE, object length for eyepiece. Clear? So H dash, which is U dash, we only take here magnitude. Now we have to find the value of tan alpha. For tan alpha, you can choose this triangle. So from this triangle, tan alpha equal to this angle alpha, H by D. So you can write directly, that is H by D. Or you can choose this triangle here, if we place there is a object, this object will be placed here, then this make a angle, this angle is alpha, or you can solve in this way also to find the angle of tan alpha. But we already know this angle is constant quantity and this is object distance or height of object which is constant and which is situated at a least distance region which is also constant. So you can directly write for tan alpha which is equal to h by d. Now use the value tan alpha and tan beta in this equation. So magnifying power of compound microscope will be then tan beta h dash by ue into h by tan alpha which is equal to d by h, and we can write h dash by h which is equal to d by ue. Okay, now look at the diagram. H dash by h, here h dash by h, we already know magnification of a lens. So what is magnification? Height of image to the, it is the ratio of height of image to the height of an object, which is the magnification of a lens. So this is the magnification, this is height of image and this is height of object, which is magnification of objective lens. So this is m naught can be write m naught equal to h dash by h, that means magnification produced by objective lens. Clear? So magnification h dash by u, that is m naught equal to h dash by h, h dash by h, which is equal to, but magnification in case of a convex lens which is positive, that is v by u. V by u means image distance to the object distance. Clear? If you take this distance is object distance and this distance is suppose that is u naught and here image distance that is v naught for objective lens. So can write here that is v naught divided by object distance here, that is u naught. Clear? Then h dash by h we can replace v naught by u naught. So this relation turn to be, it is capital M which is equal to h dash by h equal to v naught by u naught. It is v naught by u naught into d by, clear, object distance for eyepiece. But there is a negative sign. And why there is a negative sign? Because the object which is upward direction but final image which is downward direction, that means these are opposite to each other. So negative sign indicate that the final image produced by the object AB which is virtual, and here the final image which is inverted image this direction. Clear? Due to two lens. So this is inverted image this direction which are opposite to each other or which are opposite to principal axis. So negative sign is here. So magnifying power of a compound microscope, that is minus v naught by u naught d by ue, and negative sign indicate that the image, final image which is opposite direction of the object. Clear? This is upward direction and this is downward direction. So negative sign indicate here. Clear? Okay. Now you can take also a sign convention from here, h dash which is downward and this is negative sign, and here that is another quantity h is which is upward and this is positive sign, and d distance always measure from optical center. So this is negative because this is the initial ray this direction. So object which is here, that is negative sign, and again ue also here negative sign. So negative cancel, only one remaining quantity, that is my negative quantity which is here minus quantity. Clear? So you have to write magnitude wise and finally you have to place a negative sign here, and negative sign indicate that final image is opposite to the object. Clear? So this is general definition or general formula. Magnifying power of a compound microscope, that is m equal to minus v naught by u naught d by ue. Clear? Now we have to find two important cases. Case 1. So first we will discuss case number 1. So what is case 1? In this case we have to find maximum magnification. Clear? Or maximum magnifying power of compound microscope. This case, for maximum magnification we have a relation lens formula, that is 1 by f equal to 1 by v minus 1 by u. So for maximum magnification this angle alpha should be greater. Why? Because we have relation that is m equal to beta by m equal to beta by alpha, and this beta should be maximum. If beta should be maximum, then magnifying power of this compound microscope will be maximum. So when this beta will be maximum? If we decrease this distance, then this beta will be increased. Then this beta will be increased. So for maximum magnifying power, we use here that is V. That means V means final image, and that is VE here. The final image or image distance from the second lens or eyepiece, that is VE, which is placed or which is nearly equal to distinct vision. So here we can write VE equal to minus D. Why minus D? Because all the distance are measured from optical center. This is optical center and this is initially traveling this direction. So here VE equal to minus D. And what about U? And U is here. This is V equal to minus D, this is V equal to here, this is V equal to minus D, and U, and this is U, object distance here, and this distance is object distance. So in direction of ray, incident ray this direction, and object distance which is opposite to each other. So we can write here minus U E. Clear? And F is turned to, that is positive. Why? Because the focal length of lens, the focal length of convex lens is always positive. Now use this value here. So 1 by Fe equal to 1 by V, V equal to minus D minus 1 by minus U. So minus U. Then we can write 1 by Fe equal to 1 by or minus 1 by D. This is minus minus plus 1 by UE. But there is a relation D by UE. Now multiply on both sides. Now multiplying on both sides by D, capital D, then we get a formula that is D by Fe equal to minus D by D plus D by UE, and D here cancel, minus 1. If you take this minus 1 to left hand side, and 1 plus D by Fe equal to D by UE. Clear? And D by UE, this is suppose equation number 1. Now using this value in equation number 1, so from equation 1 we can write magnifying power, or this magnifying power which is maximum magnifying power in case of compound microscope, that is M maximum equal to minus V naught by U naught into D by UE, and here D by U equal to 1 plus D by Fe. Clear? This is final magnification. And this term 1 plus D by Fe, which is maximum magnification in case of simple microscope. At that time, the object which is placed in between optical center and focus, and finally we get a virtual image. If we ignore all this diagram, all this ray diagram, then only see this diagram. This is object and this is final image, just reverse side of this image, of this lens. Clear? So there is object A dash B dash and final image A double dash B double dash, and this is magnification of this 1 plus D by F in case of simple microscope. So what is the difference between simple microscope and compound microscope? Why you use compound microscope? because the magnification of compound microscope which is equal to maximum magnification 1 by d 1 plus d by f 1 plus d by f, and here 1 plus d by f and another term multiplication term, that is minus v naught by u naught, but u naught is this distance, but v naught is this distance. This is maximum distance. Clear? So if we divide a maximum quantity divided by minimum, then total term will be greater than 1, and this term is greater than 1, then mx, this m max, which is always greater than the magnifying power of simple microscope. So we use a compound microscope for clear vision, or we able to see the clear image and magnifying image. This is maximum magnification. So next, maximum magnification. This is case number 1. We get m maximum equal to minus v naught by u naught into 1 plus d by fe. Clear? This is maximum magnification in case of compound microscope. And this total distance from lens L1 to lens L2 is known as capital L, and this length L is known as length of the tube. Length of the compound microscope, which is equal to this distance is v naught plus v ue, and you can write that is v naught plus ue. Okay, this is the total distance. If you take any assumption here, if this object, this image, that is v naught, which produced very close to the second or eyepiece, if the final image produced by objective lens very close to the eyepiece, then we can write this distance is L, and here we can write L can be write that is v naught. When this object is very close to the focus point, when this object is very close to the focus point, then image will be very close to the eye lens. So at that time here object u naught equal to can be write nearly equal to, we can write that is f naught. Clear? Here u naught, which can be write f naught, and this distance, this image suppose formed at very close to the eyepiece, which is equal to L. This is L, and L is here, that is v naught. Actually the L, which is equal to v naught plus ue, but we use assumption here this L, which is nearly equal to v naught. Now this equation turned to be then n maximum equal to minus L divided by u naught equal to f naught 1 plus d by fe. This is the general expression for magnifying power of compound microscope, and this is maximum magnification. Now discuss case number 2, that is minimum magnification. Minimum magnification or minimum magnifying power in case of compound microscope, and there is object and this is image from this point. Suppose this image which is formed this point, and suppose this point which is equal to fe. That means the image of an object AB which is equal to, we can write here, that is A dash and this image B dash, and there is a lens, and this lens is known as eyepiece. Now we have to adjust this lens L2 or eyepiece in such a way that, because its focal length, suppose this is focal length FE and another focal length is here. Now we have to adjust this focal length, or we have to adjust this lens in such a way that when the image formed by objective lens, that is A dash B dash, which lies on its focus point of lens L2. Clear? The image of object AZ B dash which lies on the focal focus point of second lens. If the object is lies at focus point, then the ray which is parallel to principal axis, after refraction through it pass this direction, and if we draw its backward action like this, and the ray which incident at its optical center travel this direction, and this is this direction, and these two rays are parallel to each other. That means when object lies on the focus point, then final image found at infinite. So here the final image VE which is equal to infinite. If we observe this point, then we get a final image at infinite, and this is known as normal adjustment. Normal adjustment. So for normal adjustment we get a minimum magnifying power, or we get a minimum magnification. Clear? So this distance is now UE, and which is equal to FE, and this is final image, and final image found which is equal to VE, and VE is here infinite. So we have a general relation, that is magnifying power M equal to minus V naught by U naught into D by UE. This is general expression. So in this case we have relation 1 by F equal to 1 by V minus 1 by U. Now use the value here, and if we use the value here, then we can write here F equal to F equal to Fe, and which is positive quantity, because focal length of lens or convex lens always positive, and V is here minus infinite, and again UE, and U is here, that is UE or minus here negative sign. Clear? Okay, if you use this value here, then 1 by F equal to 1 by minus infinite, this is minus, this is a negative sign here, so 1 by minus UE, and here the negative sign U minus plus, so you can write UE, and 1 by infinite which is equal to 0, so 1 by F equal to 1 by UE. If you multiply D here and D here, then D by UE, then D by U equal to D by FE, we can write here. So there is the term, that is D by UE can be write minus V naught by U naught, minus V naught by U naught, and into there is term D by U equal to D by FE, that is D by FE. Clear? This is minimum magnification in case of compound microscope, or this is the form of normal adjustment. For normal adjustment, this is ray diagram, and here image we get at infinite distance. Clear? Okay. Another one case you can take, if object which lies on the focus point, then U naught equal to F naught. Clear? And when object U naught equal to F naught, at that time this image, the image formed by this objective lens, and this image will be very close to the second lens or eyepiece. At that time we can write V naught equal to L. So we can write again this relation here, that is M equal to minus V naught which is equal to L divided by here U naught equal to F naught into the remaining part, that is V naught U naught D by Fe, D by Fe. This is also minimum magnification for normal adjustment. Clear? These are all about how to calculate magnifying power, and what is maximum magnifying power, and what is minimum magnifying power. Clear? These are all about. This is important long question for your council examination. So question may ask in your council examination, what is compound microscope, write working and ray diagram and magnifying power of compound microscope. Clear? Thank you.